Okay, so hi guys, good evening everyone. Thanks for joining in. Today there will be a demo class, 1 hour class, not much. I won't take much of your time on discrete maths. I am your teacher. My name is Aditya, and I currently work as a system software engineer at NVIDIA. I did my master's from IIT Madras and I had a gate rank of 502. So I've been doing this teaching job since about 2 years, and um, again, glad to teach you all as well. One thing that I can guarantee you in this demo class and any other class is I don't like formula too much. You first try to make sure you understand concepts and then introduce formulas, similar to what we do today. Discrete math as a subject is okay. This is a topic of the lecture demo class, and we will be actually doing something called counting. So I have two promises. At the end of the lecture, you will be learning something. Time is precious, so I would make sure that in this 1 hour you will actually go home by learning a few concepts on discrete maths, and also we will look at there will be no formula until and unless it is absolutely required. In this case, it won't be. Okay. So we will start with something called counting. And I'll teach you some very basics of counting. Few of you might have studied it in during our school time, but there's some more subtleties to it as well. Some interesting problems that we will see today. So let's get started. And also feel free to interrupt me anytime you do not understand anything. If you are shy enough to speak out on the mic, please feel free to type it down on the chat window. And also, I don't want this to be a monologue. All my classes, I've been telling this to people that please do not make it a monologue from my side. It should be interactive. I'm teaching you guys. Just make sure you are understanding things. And if you are not, feel free to let me know that, hey, you can also tell me to go a bit faster, go a bit slower. Um, it's all okay, right? You guys are here to learn and we'll all learn together. Okay. So let's begin then. Any questions before I start? Anyone wants to know the weightage of this subject? How much weightage is there in GATE? Yes, enough to get you an IIT. So that's the first slide. The first slide is the weightage of this subject. So it has a significant weightage on your GATE CS exam. It has roughly 10% every year, right? And why am I saying approx? There are two sets. It's an average across both the sets. But yeah, hopefully you get the idea, right? So it's 10% weightage every year for this subject, and and other things are that there are other subjects somewhat related to this subject, discrete math. For example, if you will learn algorithms, you will learn something called complexity calculations. There you will learn something called how to calculate the time complexity of some recurrence relation, right? For example, if you guys know about merge sort, it's like t of n equal to 2tn by 2 plus order of n, right? There's a big equation. So how do you solve that recurrence relation? Those are also there in discrete math. So if you know how to solve that, then that will help you in algorithms. And also it's a very scoring subject. You will understand that today only. And elsewhere, I will suggest do not leave this subject at all. Make sure you learn this subject. And like the second word of this subject is mathematics, you will have to practice. Okay. I'll give you some material as well to practice apart from the lectures where you can practice your questions from. So don't worry about that. But if you can practice, let's say an hour every day or an hour every 2 days, right? Then you will be good enough in the subject. Okay. So this is discrete maths weightage in short, but okay, let's now go into the real content of the lecture. Okay, I will give you guys some 5 minutes to solve this question. And if you have any questions for this question, which means if you have any doubts regarding this question, Feel free to ask. I will read out the question for you. Suppose you and two of your friends, which means there are total 3 people, you go to a park. You see a beautiful fountain and you want to take a picture in front of it, right? We kind of do that nowadays. It's common. Your friend wants to ensure, so you have a friend who is like, no, 3 people, not good. We'll take 2 by 2 each. Okay, first 2 people will come, then we'll take a picture, then another 2 will come, like this, we'll take a picture. How many photos will your camera capture such that you can get every group? You understood the question? Again, I need it to be interactive, not on voice, also on chat maybe. So let me know if you have any doubts in the question. Is the question clear to everyone? See, I have a bad habit of my guide in IIT Madras. So what he used to do was, when he used to teach, right? If you don't respond, I would pick out names. Okay, I don't want to do that, but I hope you get the idea, right? So yeah. Any doubts in this question? Anyone who wants to answer? I know I have not started teaching you discrete math, but still, this is a take it as a logical question. Okay, no answers. Okay, no problem. See, assume, or should do you want time to solve it? That I can do. Any one of you guys need time to solve this, or again no answer? Okay, I will take that as a no then. Okay. Okay. Suppose you and two of your friends. Let's call all the 3 people as A, B, and C. Okay, 3 people, A, B, C, person A, person B, person C. You have to make sure that 2 people come to take a picture. Right? Maybe the third person is clicking the photo. I don't know, but okay, whatever it is, it is. Let's say first A and B came to take a picture. Okay, A and B came to take a picture. It is done, finished. Right? A and B have taken a picture. You can then call a day. What are the other possibilities that you can see? One is A and B can come. Any other possibility that you guys see here? I'll give you a hint. C is crying. Right, perfect, Sneha. B, C, right? B and C should also come. Any other possibility? Okay, C, perfect. 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 Good. Any other possibility? Or is it done? How many of you say, is it done? It is done, sorry. How many of you say it is done? CA. Okay. I saw a CA. Okay. Anyone else? Any other possibility that you see here, apart from these 3? Okay. See, think of it this way. Okay, let's solve the question now using some other approach. Okay, some other way. There are 3 different ways by which you can bring 2 people and take a picture. There is no other way. Okay. Now, what I do is let's think of this question in a slightly different manner. I will have, let's say in the park, when 2 people are coming, right? Let's say they want to stand in the first place and in the second place. Okay. There are 2 places where you can stand to take the photo. Let's call them as 2 boxes. I've drawn 2 boxes for the 2 places. In the first box, I can have either A or a B or a C. Agree? Everyone agree? Either A can stand in the first, or B can stand in the first, or C can stand in the first box. Let's assume, for now, assume that A stood in the box. Okay, assume A stood in the box. So in the first box, A stood. Now in the second box, who can stand? Who can stand in the second box? You can't, like, A has already stood. So B or C. Perfect, perfect, very good. Either B or C. Okay. Now let's enumerate all possibilities. Okay. So I have those two boxes. In the first one, either A stood followed by B, and either A stood followed by C. Okay. It could also be the case that in the first box, B stood. B can also stand, right? I just took A as an example. Even B could stand. So in the second box, either A can stand or C can stand. Similarly, in the first box, C can stand. In the second box, either A will stand or B will stand. In this case, I am getting the answer as 6. In this case, I was getting the answer as 3. Can anyone tell me what is the difference here? Is one of the ways wrong? Is one of the formulae wrong? Is one of the what is something wrong here, right? See, here I'm getting answer as 3, which seemed correct. But here I'm getting an answer as 6. What is the difference between these two answers? Arrangements. Okay. Anyone else? Any guess? You could be wrong. Come on, we are here to learn. You could be wrong. Just say, no one is going to judge you, nothing. You can be wrong. Just say anything. Arrangements. Okay. Anything else? Okay. Now I will give you two scenarios. You let me know which answer is correct. Okay. The first scenario is, so we have two answers. Either the answer is 3 or the answer is 6. I will give you two scenarios. Please tell me which is applicable where. The first scenario is that you only want two unique people to come and take a picture. Okay, for example, if A and B have come, if A has taken the first spot or A has taken the second spot, as long as A and B have come together, I am happy with it. I am not concerned that A should stand in the first or A should stand in the second spot. I am happy if A and B come together and take a photo. Okay, similarly, I don't care if B stands first or B stands second. I am happy if B and C together can take a photo. Similarly, I am happy if A and C together takes a photo. I am absolutely don't care about the fact that A is standing on the first spot or the second spot. Now, given this scenario, which answer is correct? 3 or 6? Shreya says 3. Sneha says 3, sorry. 3. Everyone 3? Agree with 3? So what are you trying to say here? We are trying to say that the order does not matter. A first came or A first came second. It doesn't matter here. Come on. I just need a picture with two people at once. I get that picture. I am happy with it. I do not care about if A comes first or B comes first. I don't care about that. As long as two unique people are coming every time to take a picture. Let's say one of your friends is like this. Nahi. If A is standing in the first, A should also stand in the second. There should be two unique pictures given A and B. If A and B are standing together, A will be on the left side one time, one time B will be on the left side. Okay, the other scenario. If A and B are coming, if B and C are coming to take a picture, B will once stand on the left, then B will once stand on the right. Now, which answer is correct? 3 or 6? 6 is correct. So can I say that both answers are correct? Depending on the scenario, we will select one of those answers. Is this clear? Okay, perfect. Now, again, let's draw the two boxes. Okay. Here, as I said, in the first box, there are three choices. Either A or B or C. Okay. Once I have selected someone, in the second box, I will only have two choices. I won't have three choices because you have already selected one for the first box. So that's gone. You have two choices for the second one. And you will learn this later on. But just translating this 6 here, you will do a multiplication. It's called the multiplication rule. We will study this in detail when I teach you this topic in the class to give you 6. But the fact is, once you have selected two people, for example, if you have selected two people A and B, this formula here will also try to take B and A as a unique combination. It has taken AB, it will also take BA as a unique combination. So this 6 has kind of factored that in as well. So to not factor that out, to make sure that the order is not taken into consideration, we divide this by 2. Why we divide? We'll go later. But see, for example, for each combination, we had two choices. So if I need only one, if I'm happy with only one, A and B, I don't care about B and A, I will make sure that whatever answer I get, I will do that by 2 to get the answer as 3. Now, this in this the first slide, the scenario where the order does not matter is called combination. Now I'll talk about technical jargons and people who are, I call in Hindi formula premi, which is people who love formulas. Formula is NCR, n factorial by r factorial into n minus r factorial. Okay. Okay. So this is for formula premi. And we will go into the detail of this formula when we study the class. And basically n is 3 here, r is 2 here. If you plug in the values, you will get the answer as 3. Okay. This here, where the order does matter, is called permutation. Okay. And again, for formula premi and for people who love formulas, it is NPR or n factorial by n minus r factorial. Now, how does this formula come into picture, what it does and all, I won't be teaching you now. As I said, we are here learning concepts. In the class, we learn all this formula as well, how it gets translated to this. But logically, it should make sense by now. Okay. So this is one of the most important topics in your discrete math syllabus, permutation and combination. Now, is the topic done? No, there are a lot of different types of questions, types of tricky questions that come in the exam. You will actually have to practice a lot of questions to get a hand of it. Even I kind of struggle sometimes, but still at the end of the day, you get the answer, but you still have to practice in order to get a hold of this, especially this topic in discrete maths. Okay. This is one scenario. Let's come to another scenario, and I will tell you 99% of the people learn the formula to solve this question. Okay, but I will guarantee you won't have to learn it. Just try to understand what I'm doing here. Okay, assume that you are an ice cream seller. Okay, you are selling ice cream to a group of 7 kids. Okay, 7 kids have come to your shop and you want to sell ice cream to them. You have 3 flavors of ice cream. You have chocolate, strawberry, and mango. In how many ways can you sell the ice cream? Okay, so a simple question, which means each kid will get one ice cream, only one. Okay, not more than one, not less than one, only one. Okay, and one of the possibilities could be that all the 7 kids get chocolate. Everyone loves chocolate, let's say, all the 7 kids. So all the 7 kids get chocolate ice cream. It could also be the case that all get strawberry. It could also be the case that all get mango. Okay, clear with the very basic possibilities, everyone? It could also be the case that 3 kids get chocolate, 2 kids get strawberry, and 2 kids get mango. Okay. Anyone who wants to give any other combination? Let's see if you understood it. Any other combination that you might think? Just give out any number, anything. How about 2 kids take chocolate, 4 kids get strawberry, 1 kid gets mango. This is also possible. Any other? Anyone who would like to volunteer? Come on, this is easy. We are trying to understand the question. Any other possibility to sell 7 ice creams to kids? Come on, you guys don't want to sell ice cream to kids? 5, 1, 1, 5 chocolate, 1 strawberry, 1 mango. Good, 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 good. So 5 chocolate, 1 strawberry, 1 mango. Okay. And there are million other possibilities, right? I mean, not million, we'll have to find that out. But yeah, 250 is a very good possibility as well. 2 chocolate, 5 strawberry, 0 mango. No one loves mango, so 0 mango. I think some might not love mango, but take it. So let's not go there. One way to solve this question will be just to enumerate all the possibilities like this. Right? All the possibilities you can enumerate. That's one way to do it. Is that the right way to do it? I hope the answer is very logical. It's not, obviously. It's no way the right way to do it because it will take a whole GATE exam to do it. Just one question. So how to solve this question? Okay. This is not the same as the earlier question that we solved. No way related to the earlier question also, and no way you can solve this question based on the concept you learned earlier. Okay, because in the earlier question, once you chose someone, let's say you chose A to take a picture, obviously you cannot take A again. It's gone. Okay, so once you have chosen A, it's done and dusted. Now you have to choose between B and C. Okay? So maybe you choose B, let's say. Here, if you give someone chocolate, you can give chocolate again. Right? You can repeat your choice. You can give someone again chocolate. You can give someone again chocolate. You can give someone again chocolate. So this is called combination with repetition. You can repeat the objects that you pick. In this case, you pick the object chocolate. You can repeat chocolate because, as I said, you have unlimited supply of ice cream, and obviously you can sell more than one chocolate ice cream to more than one kid. Okay. Okay. Now, how to solve this question? Okay, and I will not teach you any formula. Okay, And again, for if people are very curious to know the answer, okay, I'll give you the formula. You must solve it on your own. Okay, you must solve using the formula on your own. It is n plus r minus 1 c r minus 1. It's a very easy formula. Yeah, and half of the 90% of the people mug up this formula. I know this very well. And R is 3 here because you're selling three types of flavor. N is 7 here. It is 9C2, and you will get the answer whatever you get within 36. Okay, so it should be done. But no, that's not what we are here to do, right? We are here to learn, not revise, not this formula. For this, you don't even need me. You just take a book and learn and go, right? So, how to solve this? Now, I will model this problem in a slightly different manner. Okay. So, how many kids we had? We had 7 kids, right? We had 7 kids. I will not take 7 kids. 7 kids. I will take. Okay. Sorry. Let's come back. So there are 7 kids I want to sell the ice cream to. For each kid, I will have a box. Like if kid gets a chocolate ice cream, I will fill that box with chocolate. If the kid gets a strawberry, I'll fill that box with strawberry and so on. So I will have 7 boxes. Okay. 3, 4, 5, 6, 7. Okay. There are 7 boxes for 7 kids. And since there are 3 ice cream flavors, I will explain you again why I did it, but I will add 2 more boxes. Why I do that, I will explain you later. Okay? But there are 7 kids. I have 7 boxes. There are 3 flavors. I will take 3 minus 1 extra boxes. So I will take 2 boxes. Okay. Now take a scenario. Let's say 3 chocolate, 2 mango, 2 strawberry. Let's take this scenario. Okay, this could be a scenario that you distribute the ice creams in this way that 3 kids get chocolate, 2 kids get mango, and 2 get the strawberry. I will place some sticks like this. There's like stick, right? To divide 2 places. I'll place a stick in this box. I will place a stick in. Uh, 1 second. Did I draw one box less? No. Okay, yeah, correct. Okay. I'll place a stick here. Now, once I place these 2 sticks, right? I will call this region the chocolate region. I will call this region the mango region, and I will call this region the strawberry region. Okay, I have placed 2 sticks to divide this entire set of 9 boxes in 3 different regions. One region for the chocolate. How many chocolate boxes are there? Anyone? Just to be sure that you guys are not sleeping. How many chocolate boxes are there here? 3. How many mango boxes are there here? 2. And how many strawberry boxes are here? 2 again. So it models the scenario of 3 chocolate, 2 mango, 2 strawberry. Okay. Now let's take a scenario which Samarth had said. So he had said that we'll have 2 chocolate, 5 mango, and 0 strawberry. Okay. So I'll place a stick here. 5 mango is 1, 2, 3, 4, 5. I'll place a stick here. Okay. Now, how many chocolate boxes are there? 2. How many mango boxes are there? 5. And there are no boxes after the second, what should I say, stick. So it is 0. Clear everyone with the way I modeled the problem? I've just modeled it. I've not yet solved it. But is it clear with this? Can I emulate every scenario now? For example, let's take an extreme scenario. An extreme scenario being 7 chocolate, 0 mango, 0 strawberry. What will I do? I will place a stick here. I will place a stick here. Okay. I'll place a stick here, I'll place a stick here. Now you will have 7 chocolate. Okay, no mango, no strawberry. Okay. So, do you agree to this statement that depending on where I place the sticks, I can get any scenario? Depending on wherever I place my sticks in, I will get any scenario. Do you agree to this statement? Okay, that's the first one. The second one is for a particular scenario. Let's take a particular scenario as 7 chocolate, 0 mango, 0 strawberry. And what I do is, let's say instead of coloring them both as black, let's say one of the stick is colored as red and one of the stick is colored as orange. Will you also agree to this statement that if I place the orange stick first and the red stick later, or if I place the red stick first, orange stick later, there is no difference with the scenario? It's still 7 chocolate, 0 mango, 0 strawberry. Do you guys agree to this? Does it matter if I place the red stick first or the red stick in the second one? I will still get 7 chocolate, 0 mango, 0 strawberry. Everyone agrees to these two statements? Okay. So now your problem is of a different dimension, different type. Your now problem is this. You have 9 boxes. Okay? You have 9 boxes. You have to place 2 sticks in those 9 boxes. Agree? You have 9 boxes. You can place 2 sticks on that 9 boxes. For example, where can you place the first stick in? Any of the 9 places? Is it clear? Are you guys following? The first stick you can place in any of the 9 boxes. Do you all agree to this? Okay. And the second stick you can place in still 9 or 8. The first stick you could place in any of the 9 boxes. Let's say that the first stick you placed is here. Now this place is gone. How many places remain for the second stick? 8. Very good guys, very good. You understood it, very good. So 8 sticks you can place for the second one. Now let's take the orange stick. Let's say in the remaining 8 places, you place it here. Now, remember your second statement. If I place the orange stick first and the red stick second, will it make any change in this scenario? About 3 chocolate, 2 mango, 2 strawberry? But 9 into 8 method we are taking into consideration. So what should I do? I will divide this by 2. And what do I get? 36. People who wanted formula, what will you get? N plus R minus 1 is 7 plus 3 minus 1, C 3 minus 1. Okay, now this is 9C2. This is 9 factorial by 2 factorial into 7 factorial. Okay, and people who are knowing factorial, you can write this as 9 into 8 into 7 factorial divided by 2 factorial is 2 only times 7 factorial. You cancel 7 factorial to get the same answer, 36. This is for people who love formulas. Okay, but is this formula clear now? With this scenario? Yes, I will tell you 90% people mug up this formula, but if you understand the concept, it's very simple, guys. It's not very difficult. See, you just had to divide your set of 9 possible slots in such a manner. So there's another, like, if people love technical things, right? I don't speak much technical words, as you might have seen by now. I don't feel that cool by speaking all that, but still, if you want to divide a region across n different groups, in this case, if you want to divide this entire set of 9 boxes into 3 different groups, you will need 2 dividers. If you need to divide across 4 different groups, you will need 3 dividers. Okay, and that's your next question. The next question is, let's say that instead of there being 3 flavors, let's say there was 4. Someone came and told me that, boss, vanilla to nahi hai. I love vanilla, and vanilla ice cream is my favorite. You're not selling vanilla. And for me, boss, sure, I will add a vanilla for you as well. Okay. So you have 4 flavors of ice cream. Okay. And earlier, up to people who liked vanilla will also come, right? The kids who like vanilla. Earlier, they were not coming. So instead of 7, now there are 9 people who come. Okay. I'll change the question a bit. Okay. So instead of 7, 9 people will come. And now instead of 3 flavors, you added vanilla as well to your menu. Okay. So you added vanilla as well. Let's say vanilla is V. Just another flavor. Okay. Vanilla V. So now what should I do? I will draw 9 boxes for each of the 9 kids. So let's say 9 boxes are here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And also, as I said, I will add 3 more boxes. There are 4 different flavors, so I will add 3 more boxes. Okay, and let's say the first region is chocolate, second region is mango, third region is strawberry, fourth region is vanilla. There are 4 flavors now. I will just place random 3 sticks. You guys tell me what is the configuration I'm talking about. I'll place a stick here. I will place a stick here. I will place a stick here. Can anyone tell me how much chocolate, mango, strawberry, vanilla is being sold? Two, three, three, one, right? 2, 3, 3, 1. Very good, guys. Okay, you guys know more than me now. Very good. So, 2 chocolate, 3 mango, 3 strawberry, 1 vanilla. Can anyone answer the question now? You need not write the entire formula. You can just write the formula. You need not calculate it. I am not, I'm okay with, I know you guys know how to multiply and divide. Now, can you answer the question? Can you solve this question? How many boxes are there in total? There are 12 boxes in total. You have to place dash number of sticks in those 12 boxes. How many ways are there? There's this very small thing here which you might miss. Let's see. What value will you divide it with is something that, let's see. You might make a mistake. That's okay. We'll learn. Anyone who wants to answer? It's okay if it is wrong. Here no one is giving you marks and all. So please feel free to answer. Yes, there are 13 sticks, 12 slots. 12 into 11 into 10 by 4. By 4, by 3. Yeah, that's where people will make mistake. That's what I'm saying. Okay. Now think of it this way, right? So let's color those sticks out. Okay. Um, this is one stick. Where was 3? Yeah, here. Okay. And where was this orange? Here. Okay. This is one way of for this configuration. I mean 2, 3, 3, 1. Right. Another combination could be this. Hey, sorry, I moved it. 1 second. Sorry. 2, 3. Okay. This is one. I don't know the answer. Um, I will have to check. But yeah, okay. Let's see. Okay. Um, Even I'm solving it for the first time. But take it. This is another way. But it still is 2, 3, 3, 1. Okay. 2, 3, 3, 1 still, right? I mean, there is no change here. There could also be a case that the red is on the. So, okay, think of it this way. Okay, let me explain it to you in a different manner. The denominator. How many sticks can. Okay, sorry. Let's take the very one combination of 2, 3, 3, 1. Okay. In this position, you will place a stick. Agree? Agree? Everyone agree? You'll place a stick here in this position. How many sticks? How many different choices you have? You still haven't placed any sticks. You want to place 3 sticks. So in the first position, you can place any of the 3 sticks. Agree? Agree? Everyone? No doubt till now? Okay, perfect. So you have placed 3 sticks. Let's say you place the orange stick. Okay? अभी के लिए. Let's take you have used the orange stick for now. In the other scenario, where is 3? 1, 2, 3. Here, how many sticks you can place here? How many choices you have? You had an orange, a red, and a black stick. So you have already placed the orange stick in the first position. How many sticks can you place here? Either the red stick or the black stick. So how many ways you have? 2. Agree? Everyone agree, right? No doubt still now. Please ask if you have a doubt. It's okay. You can't place the same sticks because you have already used one stick in the third position, right? You have already used the orange stick. So you have a red and a black stick. So if you have placed the orange stick in one of them, then obviously you will have 2 more choices to place the in the second stick. Okay. Let's say that you have placed the red stick here. So how many choices remain here? Just the black stick, because already you have placed orange, already you have placed red. You don't have any more choice. So you can only place the black stick here. So 3 choices you had for the first one, 2 choices you had for the second one, only 1 choice you had for the first one, total 6. That will be your denominator. If you did not understand this, don't worry. Okay, don't worry at all. We'll go into detail here. I'm in a demo class, so I'm trying to abstract things out, but still hope it is clear now, which is this is nothing but 3 factorial. Okay, this is nothing but 3 factorial. First choice you had 3, then 2, then 1. So you apply the multiplication rule to get 3 to 1. Okay, 3 into 2 into 1. So again, let's come back. Okay, you have to place the stick. The first stick you can place in 12 different places because you haven't placed the stick anywhere yet. So you have 12 choices for you. Then you will place the second stick in the remaining 11. Then you place the remaining in 10 divided by, you have placed the 3 sticks. Now they can rearrange among themselves that you don't want to care about. So you have to divide by 6. So if you try to calculate, you get 220. Anyone who got the answer 220? Samarth. Good. Very good. Anyone wants to solve one more question, or is it's okay for today? You can say it's okay for today. You can say we can. Anyone wants to solve another question, variant of this, or okay with this? One more? Okay. Okay. Now do one thing. I'll keep this as 9. I won't change the number of kids, but you have introduced another flavor called butterscotch. Butterscotch is also one of the very good flavors of ice cream. So you have now, instead of 4, you have 5 flavors. If you guys have a pen and paper now, please try to solve. I'll give you 3 minutes. Then we'll discuss the answer. You have 5 flavors instead of 4. Sorry, I was on mute. Yes, anyone? How many boxes you will have? 9 kids, 5 flavors. How many boxes? 14? 13. Yeah. Okay. So 13 boxes, you have to place how much? 4 sticks, right? Because if you place 4 sticks, you can divide it across 5 different regions. So what will be the numerator? Anyone? What will be the numerator? 13 into 12 into 11 into 10. Very good. What will be the denominator? 4 factorial. Okay, now we are talking in formulas. Very good. So the first, let's say, okay, 1 second. So I do not have space, I guess. Oh, I have. Oh. So, so let's say the 4 sticks were red. So I'll call it S1. Sorry if there was a beep. I think I have to turn this off. So there was another one, let's say orange. There was another one, let's say, oh, yellow would be confusing. Let's say green. Okay. And there was another one, let's say black. Okay. So if you fix one of the configurations, fix any of the configuration, let's say 2, 1, 1, 1, 2. Okay. So let's take a configuration 2 chocolate, 1 mango, 1 strawberry, 1 vanilla, 2 butterscotch. Okay, so the you can, if you want to place the sticks in, you have 4 choices for the first place. Either you can place the red or the orange or the green or the black. For the second slot, you will have 3 only because you have used one of them in the first slot. The next one you will have only 2 choices because you have placed 2 sticks in the first 2 slots. And finally, you will have only 1 choice. And you will have total 13 different slots to fill in, times 12 times 11 times 10. So the first stick you placed in any of the 13. Next stick you will place in the remaining 12. Next stick in the remaining 11. Next stick in the remaining 10. But here you will count the order as well, like, right, permutation as well. So you'll have to divide by this 4 into 3 into 2 into 1, which is 24. You will get the answer as 715. And to people who can solve, who were able to solve, very good. Who were not able to solve, don't worry. This class is for you only. We'll go deep dive into it. I just tried to explain you things here. For example, Samarth has written the formula. Eventually, the idea will be for you to go to this formula and try things out. But my intention is not to teach you formulas. Okay, my intention is teach you first the concept, then I will steer you towards the formula. Okay, so is this clear, everyone? Okay, perfect, 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 perfect. Thanks. Okay, perfect. So this was a basic demo class, as I said. For now, we'll have a lot of things to learn in this subject. This is just one of the things, okay? And it's very interesting subject if you start, what shall I say? Start solving questions, start learning the concepts. It's a very scoring subject, very interesting subject. In particular, this is the syllabus of your subject. Okay, we will first start with something called propositional and first order logic. Again, it's a topic, right? Then we will start with a topic which you might have studied in your school, college, wherever, called sets, relations, and functions. It's the same one, there's no difference, but we'll still learn it, don't worry. Then we'll go into something called partial orders and lattices. Then we'll talk about monoids and groups, group theory. Then a very important topic, even for your algorithms, graphs, graph theory, in particular connectivity, matching, and coloring. And then we end with combinatorics, which has 3 different topics. One is counting. We have looked at some part of counting today, that's why it's in bold. Then also recurrence relations are there, which is like, if you have seen those time complexity equations, right, for merge sort, binary search, and all that. So it's a bit more complicated here because you will have much more complicated recurrence relations and generating functions, which is an easy topic. Okay, so this is basically your syllabus for the subject. And we will start with propositional first order logic in the first class. That will take some time, 3-4 classes. Then we'll eventually go to the others as well. This has been directly copied, pasted from the GATE syllabus. So, okay, these are the topics that we will cover. Okay. So before I end, is there any question that you guys have? Any questions? No questions? Anything related to discrete math, anything related to GATE, anything related to strategy, anything related to problem solving? Okay, let me ask myself a question. If I was a GATE student, and then I will answer myself. So what is a book from where I can practice questions? As I said, this is a mathematics subject, so you will have to practice more and more questions. So what is one book you can use to practice? The book name is, and again use this for practicing questions. As far as the concepts are concerned, this lectures would be enough, and half of my quizzes will also come from the same book. So please try to get a hold of. You don't have to buy the book. There are PDFs available. Uh, Try to solve questions from the book. Discrete Math and its applications. By Kenneth Rosen. Okay. There are some other books as well. If you feel comfortable with the other books, it's absolutely okay. The idea is to solve more and more questions. But if you are not, if you're still thinking about what books I should use to practice questions, this book has a lot of questions for you to practice. You will get tired solving questions if you just use this book. So, and also I will give you quizzes and problem sets, and I will solve a lot of questions as well in the class. But if you still want to solve more questions to strengthen your concepts, this is one good book. Okay, that's one question I asked myself and I answered myself. So, any questions that you have? No questions? Okay. Okay. So we'll end the class. Thank you for joining. I'll send you the slides here so that you can download and send out a download link. Yeah, okay. Yeah, I forgot to send, but yeah. Okay. So I will send the slides here. Okay, and you can also, okay. Here is the thing. Okay, let's ask you a very basic question regarding gate. Okay, this is not regarding discrete math. According to you guys, which subject is the most important for gate? Don't say discrete math, okay? I am not discrete math paper setter, so I won't be happy by hearing that. According to you guys, which is the most important subject for the gate exam? DSA, very good answer. Any other? Don't say all, okay? All is also not a good answer. DSA is a good answer. Okay, so I will suggest one small thing to you guys. ये सब तो होता रहेगा, right? Your system subject, networking, databases, DSA, and all will happen. Please keep on revising your C, okay? And one thing that I did in the previous class, and this students only, I did it once and the students liked it, so I did it again and again, is after every class, when I teach you the subject, for example, I teach you discrete math, let's say, after every lecture, one of the most trickiest subject in the entire GATE syllabus is your C, programming in C. Okay, there's a lot of tricky questions involved. So please start your C programming concepts learning as soon as possible. And after every live lecture, what I do is it's for free to you guys. I mean, I do not need any credit, nothing and all. We solve some tricky C questions. I used to do that last year with the students. They used to like it, saying, "Hey, boss, hey, good. I know someone will teach you C as well." So, but still, there are many tricky questions that can come in C. So, one thing that I always do is after every lecture, I bring up a C tricky question for you to solve, and 99% of the students would make a mistake, and that's the whole idea, because then you will also learn. Okay, so that's one thing that I will suggest. Please put up your C as soon as possible. Okay. Okay, I don't have anything else to say. If you don't have anything to ask or say, please feel free to exit the room. Thank you for joining. The class is over.